Hello, everybody. My name is Thorsten Grabs, and I'm a program manager on the Azure SQL Database team. Today, we are going to talk about multi-tenant SaaS applications and how you can power them with lots of Azure SQL Databases. So we're going to spend most of our time with SQL Databases. You can see that's an area within the data bucket in the Azure Platform Services. It builds on top of our data center infrastructure services. And most of all, we're going to spend time with the new Elastic database capabilities that we have recently added to SQL Database in Azure, which makes building multi-tenant SaaS applications so much easier. So with that, I want to spend a minute to introduce you to Azure SQL Database. It's a global and fully managed database as a service in Azure. It builds on SQL Server technology. And one of its great benefits is that it allows you to really cut down your administration time and administration cost. So as part of the service, you're getting high availability and failover capabilities. An SLA that we provide for each database is 4 nines of availability. The databases are secure, protected, and compliant, and they're fully compatible with SQL Server 2014. They're built for SaaS applications, particularly when you need to create new capacity, when you onboard new tenants into your application. You can simply create new databases in Azure SQL DB, and you will have additional resources, additional capacity available. So it really follows the pay-as-you-go model in the cloud. And what I want to do today is use a demo application to walk you through 4 challenges to illustrate the new Elastic database capabilities that we've added and that make it much easier to build SaaS applications in Azure. What I've put together is a ticket sales application that's multi-tenant, and it's called Wingtip Tickets. Let me show you that demo application in action. And as you can see here, the first tenant that I have is Contoso Concert Hall, and it has a ticket sales experience here that's tailored towards more classical content. A second tenant here is completely different. It's a judo club, and it has different events. Again, you can purchase tickets for these events through the website. And the third tenant that I pulled up here is a jazz club that, again, sells various tickets for different events. And the application is mostly functional. So let's assume I'm interested in classical music. I can log into Contoso Concert Hall as a customer and purchase tickets. And once I'm logged in, I can pull up the seating chart, look at different prices for different sections, change the quantity of tickets that I want to buy, and then put in my payment information. So all of that is powered through different Azure services. Obviously, we're using Azure SQL Database to store the data for the different tenants, and 3 of them you've seen here in the browser. We are also using Azure Cloud Services to run the business logic for the application. And last but not least, we are using Azure Traffic Manager to provide different DNS names for the different tenants of the application. So you can see here in the URL is Contoso Concert Hall. For the Judo Club, it's Dogwood Dojo, and Fabricum Jazz Club for the Jazz Club. And that mix of different Azure services is quite a typical architecture that we've seen lots of customers and partners use for multi-tenant SaaS applications. And if you look at this picture here, it's fairly straightforward, fairly easy to scale these applications. So first of all, if you need to scale the cloud service itself, you can do that through using auto-scaling for the cloud service. If you look at the data tier, you already see me showing on this slide multiple databases. So as new tenants get onboarded into your application, you can scale the data tier by simply creating a new database for each tenant that you onboard, and that gives you additional capacity, additional resources for each tenant. Also, you can adjust the capacity and the resources individually for each tenant by changing the performance tier for the database that's hosting the tenant's data. In order to keep track of the databases in the data tier and the mapping of different tenants to the databases, you typically use something like a customer catalog or a metadata database that holds this information and holds the mappings of tenants to different databases. So what I would like to do today is walk you through 4 key challenges that you're going to face when building applications of this type. And I would want to introduce you to the different Elastic database capabilities that we've added to a SQL database in Azure to make building these applications much, much easier. And the first challenge that we're facing when building these applications is how do you keep track of the different databases in your data tier? How do you manage membership in the set of databases? How do you add and remove databases for new tenants or for tenants that you need to drop? And how do you then broker connections for incoming requests into the right databases, into the right places through your customer catalog? To make this easier for application writers, for developers, and to avoid you having to write too much boilerplate code, we have put together a set of patterns in a library that you can use in your Azure applications. And the library is available on NuGet. So if you go into NuGet and search for Elastic Scale or Elastic Database Client, you see the first hit here is the Elastic Database Client library. And you can simply add that as a NuGet reference through the NuGet Package Manager to your Visual Studio application. I've done this here. So this is the Visual Studio solution for the Wingtip Tickets application that you just saw in action. And if I pull up the references over here in the solution, you see the Elastic Database Client library here as one of the references in the project. And it's great because it helps me manage the metadata that's stored in that metadata customer database. And I don't have to worry about the code in my application to add new databases, to remove databases. But most of all, it helps me also brokering connections for incoming requests into the right databases for a given tenant. And here, what I've already highlighted through the breakpoint that I have set in the code is a statement that helps me with that aspect that we call data-dependent routing. So what this request does, it basically goes against the metadata abstraction. It's called customer shard map here. And the open connection for key method then brokers a regular SQL Server connection in ADO.NET for me based on information about the tenant. In this case, it's a tenant ID, which is simply a hash over the DNS name that's used for that tenant. And once the connection has been brokered, it's just a regular SQL connection. And I can run regular SQL commands with regular T-SQL statements against it. I can use SQL adapters or SQL data readers, just a familiar SQL ADO.NET programming experience. So let's see how this works. Over here in the Server Explorer, you can see my Azure subscription. And this is the cloud service that is running my demo application. So let's attach the debugger to the running application in Azure. And let me scroll down to the process that's hosting the business logic. And as we are attaching the debugger, you can see the breakpoint is already live. So let's jump over here back into the browser. And let's just refresh the page for the Judo Club. And what we'll see happen in just a second is we hit the breakpoint here, and you can see that the connection right now is null. As we execute the open connection for key statement, based on the tenant ID hash, a regular SQL Server connection is opened into the right database for the Judo Club. As we look into the connection string for the open connection, you can see Dogwood Dojo as the database here. So that's great. Let's try this out for a different tenant. Let's go into the Jazz Club, refresh the page. And we're hitting the same breakpoint again. Initially, the connection is null. As we execute the open connection for key statement, we get back an open connection that points to Fabricum Jazz Club right now because of the different tenant ID. And that functionality is part of the Elastic Database Client library that we have added and built on top of the metadata that you also manage through the client library. And it helps me avoid writing a lot of boilerplate code that I would otherwise need to do the management for the metadata and the connection brokering. So if you look at this, let me detach the debugger first. So as you look at this, the functionality that we just saw is what we call data-dependent routing. A request comes in that's referring to the DNS name of one of the tenants that we are running. And that is being used by the library to look up the correct tenant from the catalog and then broker the connection into the right database. And in that, as soon as you're connected to that database, you can just run regular SQL statements in the database through the library and ADO.NET. A great benefit of the library is that it makes these lookups very, very efficient because it allows you to cache the metadata in the application process. So as the cache builds up, you do no longer need to do a round trip into the customer catalog database and the metadata to broker these connections. So that's great, and it gives you great performance for these cloud services, in particular when you scale them out and you have lots of users connecting to your cloud service. So that's the first major challenge. How do you keep track of the databases in your data tier, and how do you route requests into the right places? And that challenge is addressed by the Elastic Database Client library that we just saw in action. The next challenge that I want to introduce you to is how to manage your data tier and database performance at scale. So as you start out with just a few databases, it might be possible for you to adjust the performance tiers and the resources for individual tenants and for individual databases. But as you get into the tens, hundreds, or even thousands of databases in your data tier, that becomes very cumbersome. And you certainly don't want to micromanage performance tiers for individual databases when you have thousands of tenants. And a great way to deal with that challenge is what we call Elastic Database Tools. Elastic Database Tools allows you to allocate an overall amount of capacity and resources for a whole set of databases. And you can create as many databases as you need in the pool, and they will draw their capacity from the overall capacity that you've allocated to the pool. Let me show you that capability in action in the Azure portal. And as I bring up the portal here, what we're going to do is we're going to jump to the pool that I have defined for the Wingtips application that we just saw. And I have a tile for this here on my home screen. And here you see the pool that I have defined, and you see the monitoring statistics, the essentials. What we can do now is we can configure the performance for the pool as a whole, as I mentioned. And as the blade populates, you can see that I can set overall amounts of capacity, and they're expressed as database throughput units, which is the metric that we're using to measure database performance. The pool right now is configured for an overall amount of 200 Elastic DTUs. And you can see by looking at the monitoring chart above that this is plenty for the traffic that is currently hitting the databases in the pool. And remember that all of the databases, and I have 32 of them here in the pool currently for 32 different tenants, All of these databases draw from the overall capacity allocation that I have configured for the pool. If I wanted to, I could adjust this up to 400 or 800 DTUs, or since the pool is not used a lot, I could go down to 100 DTUs. So that's the overall capacity allocation for the pool. And as I create new tenants and create new databases for new tenants, I simply create the new database in the pool, and as soon as the database is live, it will start drawing its capacity and resources from the overall allocation that I've done for the pool. So that's how you configure performance for the pool as a whole. In addition to that, you can also control the capacity and utilization boundaries for the databases in the pool. And there are two settings that you can control here. The first one is when you have a performance spike in one of the databases, how far do you want a database to go up in terms of the capacity that it draws from the pool. And I've set this to the maximum here, which is 100 DTUs. So that allows a database to spike up to the top level of the standard performance tier in case there's lots of demands for the database that's powering that particular tenant. The second setting that you see here is the minimum DTU setting for individual databases. And I've set this to 0, which essentially means that I allow databases in the pool to go dormant. I could also bump this up to 10 or 20 if I wanted to reserve a minimum amount of capacity for each database that I have in the pool. So that's what I'm running right now for the application that we just saw. It's also very easy and very straightforward to add a new pool for an existing server in SQLDB for an existing set of databases. So here I have a similar server in Azure SQLDB with 31 databases in it. And if I wanted to put these databases into a pool, I simply go and hit the Add Pool button in the portal. I can add individual databases into the pool. And we have a recommender that helps you pick the right databases that's based on machine learning technology that's analyzing the utilization history of the databases. And then you can configure the performance for the pool and for individual databases in the pool, just like we just saw for the existing pool. So that's Elastic Database Pools in a nutshell. And for these applications, it really helps avoid a lot of the micromanagement of capacity and performance for individual databases, particularly when you have lots of tenants and lots of databases. But it typically also comes with a cost benefit for you, because in most cases, only a few of your tenants are active at any given point in time. So if you were to provision your individual databases for peak capacity, you would have a lot of idle capacity sitting around. By using a pool, you can cut down on the amount of idle capacity that you're paying for by just allocating the resources in the pool that you need in aggregate for the maximum capacity that's drawn by all your databases in the pool. And that typically gives you cost benefits as well, because you basically share capacity between the databases that you have in the pool. So that is the second challenge, and the feature in SQL Database that helps you address that challenge is Elastic Database Pools. Let's move on to the third challenge. Imagine you have tens or hundreds of databases in your data tier for your application. And everything works fine, obviously, when you're using the library to connect to individual databases and run transactions or requests for individual tenants. But think about scenarios where you want to run a port that stretches across all of the databases or across all of your tenants. And that, obviously, you don't want to go into a tool like Excel or Power BI and then open up 100 or 1,000 individual connections to individual databases. What you would rather like to do is open a connection into a single database, like the Elastic Query database that you see here on the slide, and then leave it to that database to do the distributed processing behind the scenes and get all the data back from your data tier and assemble an overall result that's presented back through the tool. And that's an essential capability for BI scenarios, reporting scenarios, but also for any kind of applications where you don't control the application code and you cannot inject, for instance, a library like the Elastic Database Client library. So let's take a look at this capability, and the capability that provides you with this experience that I just described is called Elastic Database Query. And it ties back to the metadata that is created through the Elastic Database Client library. And let's jump back into Visual Studio and move over into the SQL Server Object Explorer. And there we'll actually get a view of the database topology that's powering the application. So you can see one logical server that I have in SQLDB, which is the catalog server. And here you see the customer catalog that's storing the metadata for my data tier. And here you see the Elastic Query Database, which we will use in just a second to run queries that stretch across all of the databases in the data tier. Down here is the actual data tier in this logical server, and you can see the various different databases that have been created for the different tenants in the application. So for instance, here is Contoso Concert Hall. We saw that. Here is the Judo Club, and down here is the database for the Jazz Club that we just saw. And there are others in there. And you can also see that the schema is the same in all of the databases in the data tier. So what I'm doing now to illustrate the Elastic Database query capabilities is we're going to connect to this Elastic Query Database over here. And I've already done that. And in order to use the Elastic Query Database feature, there are basically two steps. The first step is a first-time only step where you perform a number of DDL statements that tell us more about the metadata and that gets Elastic Query configured for your scenario. And then once you've done that, you can then, in the second step, run any SQL queries across the Elastic Query setup that you have configured. So here I'm already connected to the Elastic Query Database. As you can see here, the connection should be ready. The first step that you take to set up Elastic Query is to create what we call an external data source. And that really tells Elastic Query about the customer catalog and the metadata that you have for your data tier. Here, the external data source that we are creating is of the scaled out type, which we call Sharp Map Manager. And the metadata is stored in this server, in this database, and it can be accessed through these credentials that I've defined previously. And the metadata in that database is tagged with the tag customer catalog. So I've created this external data source already, and we can look it up through this catalog view here. And you can see it's this row that you see in the catalog view here. Once you've defined the external data source, the next step is to define external tables which provide a representation of the individual tables that live in the scaled out data tier. And the first part of the external table definition is just to tell Elastic Query about the schema of the table that we're going to query, and that's physically stored in your data tier. And the second part is then where does Elastic Query find the metadata for it? And that's where we refer back to the external data source that we have just created in the previous step. And then the last piece is which data distribution scheme is being used to distribute the data in your data tier. And so this was the first table, which basically goes back against the customer configuration table, which is this guy in the underlying databases. And here is the statement that I would use to define a second one, country, with somewhat different schema, but the same data source and the same distribution. Again, I've pre-created these tables to save us some time. Here's the customer configuration, and here is the country table. So something that we can do now is, once we have defined these external tables, the Elastic Query Database knows about the schema of the table that's physically stored in your data tier. It also knows how to access the individual databases in the data tier through the external data source. And now we can submit a regular SQL query against the external tables that we've just defined This one that I just ran runs against a customer configuration and does some simple grouping and counting over the themes that customers or tenants are using to configure their experience and their websites. So you can see that we have about 4 tenants that are interested in dance, 7 tenants are using a jazz-focused experience, and then you have a number of tenants that are using symphony and theater as well. So that might be an interesting simple report to just see what kind of templates your tenants are using across your application. Another interesting query that you might want to run is which countries are configured by your various different tenants that you have in your application. And you can see across all of these 32 databases that are currently present in the data tier, all of them are just configured for the United States. So very straightforward. And now, after these few DDL statements that I just ran initially, you can see how easy it is to run simple T-SQL statements queries that retrieve data that's physically stored across many databases in the data tier of your application. And that's the T-SQL experience. Let me jump over into Excel as well and show how you can do simple reporting now against this configuration. Let me connect to the server that hosts the Elastic Query database, the endpoint. This is the database where we just defined the external tables. Those are the 2 external tables that we just defined through the DDL. Let me pick the customer configuration here. I'll just hit next. Yes. And let's just add a table into Excel. And you can see that this table now shows me all of the rows that are in the configuration tables across all of the databases that I have in my data tier. And I could get that report, I could get that result by simply connecting to a regular SQL Server database in SQLDB through Excel. And from that point on, I can use that connection to do fancier things in Excel. For instance, I could do pivot tables. I could also go into Power BI, or I could use SQL Server Management Studio for that matter, connect to the same database, and then run SQL statements against my Elastic Query endpoint. So that's a great experience for scenarios where you need to do interactive querying across a set of databases through various different tools, like the ones that I mentioned, Power BI, Excel, or even Management Studio. A different scenario, though, is when you need to do asynchronous querying or asynchronous T-SQL statements that you need to run across the data tier. And that's the 4th challenge, which I call managing sets of databases. And the typical scenario is when you do a change to your application and you need to roll out a schema change across all of the databases in your data tier. How do you do that at scale? Or how do you update statistics or rebuild indexes in all of the databases that you have in your data tier? Obviously, you don't want to connect to each database individually and then run the T-SQL statement for that yourself. Instead, what you would like to have is an experience where you just drop your T-SQL statement into a well-defined place, and then a service behind the scenes takes care of farming out that statement to the different databases, keeping track of progress and making sure that the statement eventually completes across all of the databases. We do provide a capability that helps you exactly with that scenario in SQLDB, and it's called Elastic Database Jobs. So let me illustrate that capability to you. And it's very nicely integrated with Elastic Database pools that we just saw previously. So here we are back in the Azure portal. Let's go to the Elastic Database pool that we have defined for my application. And you can see here in the pool at the top, you have the ability to create new jobs or to manage existing jobs. Let's just create a new job here. And I need to first log in. And let's jump back here. And let's say we want to add a new piece of reference data to the country table. And let's add these 2 rows so that the application supports the United Kingdom and Germany in addition to the United States that we currently have. And let's provide credentials for the job. And let's copy that statement into the create job blade here. So we've given it the job name. We have given it the credentials to run the job with. And down here, you can see the T-SQL statement that we want to run across all of the databases in the pool. Let's submit that statement. And it takes a couple of seconds to register the job, and it will bring up the managed job experience. And you can see that I've run already a number of jobs across this pool. At the top is the one that we just created. And it also pulled up the details blade for this job that we just defined. And as we scroll down, you can see how the job is making progress against the different databases that I have in the pool. You can see that some of them are already completed, while others are still running. So let's give this a few more seconds to run to completion. And I think it just completed right now. So what happened behind the scenes is that T-SQL statement was basically picked up by the jobs framework and then run as individual tasks against the databases that I have in the pool. And you can see the status and the completion results for the different tasks here in the portal as well. So let's validate what the job did by going back into T-SQL and into Visual Studio. So remember that we just added essentially 2 rows into the country table through the job that just completed. Also, we defined an external table for the country tables in our data tier. So what we can do now is use that query that we just ran, and you still see the result down here. So we just saw United States for the 32 databases, and that was the previous result. Let's rerun this query. And now you see that Germany and the United Kingdom has been added to all of these databases. And we can basically use Elastic Query to validate the rollout of the reference data that we have performed with an Elastic Database job. So that was the 4th challenge. How do I manage large sets of databases at scale? And we used Elastic Database jobs to make this much easier for your Azure application. And with that, I want to wrap up this session. So first of all, I would like to encourage you to try the Elastic Database capabilities with your applications. And a lot of the functionality that I just demoed is in preview right now. That's true for Elastic Database Pools, for Elastic Query, and Elastic Database Jobs. So please try these features and let us know your feedback. And on this slide, you also have a number of links that you can use to learn more about the Elastic Database capabilities. The first URL here is a pointer to an overview document that illustrates the various Elastic Database features and how they play together. And then I've added pointers to the individual features, database tools, database pools, query, and jobs. And I encourage you to check out these URLs and use those capabilities for your applications in Azure. It really makes life much, much easier when building scaled out multi-tenant SaaS applications. So thank you very much for listening, and have a great day.